Great. So welcome everyone to the community meeting for December. So today we're going to go, over the usual monthly stat updates. We have some workload updates from Vivek, and there's recently been some work on having an importer for ONNX in Torch-MLIR, and this is the first time that I'm learning about all of this, so this is very exciting. Vivek will give us some information on that as well. So before we get to that, just a reminder. So this is our monthly community meeting. It happens the first Monday of every month at 9 a.m. And it's a recorded meeting. We post the recordings on YouTube. If you're not able to make it, you can always check out the meeting there. We also have a developer hour the second and fourth Monday of every month. And every Thursday, I host office hours as well. So office hours is more for like very entry-level questions regarding Torch-MLIR. So yeah, feel free to join that if you have any questions. And lastly, we have a very active Discord where it's probably the best source to ask any questions if you're not able to make it to one of the meetings. And there's also a calendar link if you don't want to have to write everything down by hand. We have a calendar for all the events. These are some of the statistics for this last month period. So we had 40 commits from a variety of contributors. So thank you everyone for all the hard work that you've been putting into Torch-MLIR. And so now I'll pass it on to Vivek for some workload updates.
Yeah. Hello, everyone. Welcome to the Torch-MLIR monthly meeting. So regarding the workload updates, I think we don't have any new set of models. So these models were, I think the update is same as the previous month one. We have the Llama 2 supported and the Falcon 180 the giant model, both the quantized and the non-quantized one being supported through the Torch-MLIR. The so that is regarding the set of models that we support now. Apart from that, so the TorchOnnx is a new kind of sub project that is being integrated into the Torch-MLIR previous month. So actually, thanks to Stella, who's the actual contributor of this, I'm just helping her side by side for the op support and all those stuff. She hasn't been able to make up for this meeting, so I'm presenting this on her behalf. So like if you have some real in-depth questions regarding the TorchOnnx, then maybe you can ping her on Discord or the Torch-MLIR channel regarding the actual rationale behind this adding this stuff. And there is also an RFC on the MLIR discourse where you can find out some of the discussion going on behind adding this as a sub project in Torch-MLIR. So I hope you all must be familiar with the ONNX MLIR originally being present as another separate project which is being used to import the ONNX models via the MLIR, using the MLIR and then being converted the and that IR being converted to the ONNX dialect ops, and then it is being lowered to some of the native MLIR dialects and being ultimately being lowered to the LLVMIR. So here we are using a slightly different approach, making use of the existing stuff and the infrastructure that we already have in the Torch-MLIR. So actually, the way we are doing this, or the reason behind doing it in this particular way, is that we already know that we support the PyTorch models using the Torch-MLIR. We import them using an fx importer, and then we lower them to the a10 dialect ops, and ultimately being lowered either to lineage or tosa or stable hlo. And after that, like the shark that we work on, so that takes it up from the lineage, and then use iri as the runtime environment to compile and run the model. So in the TorchOnnx, what we do is we have a Python importer. The importer right now is not part of the Torch-MLIR. Right now it is in the Shark Turbine. So we do the op level import or the model level import of the ONNX models through the this Python importer, which is right now part of the Shark Turbine. We plan to add this in the Torch-MLIR project as well, but it might need some change. And so right now that is another limitation because of which we are not able to we are not able to add the end-to-end test to just to test the lowerings that we are adding. We only have the unit test as of now. So this Python importer is there in the Shark Turbine, and what this Python importer does is it takes the ONNX model, or let's say one of the ONNX operator, and import it in the form of the Torch custom op. And then what we do is we have this Torch custom op, and since we are doing it this way because we assume that, because the I won't say we assume, because of the thing that the ONNX operators and the Torch operators are, it's in the in at the abstraction level they are kind of somewhat similar, and that is why how it enabled us to do it in the way of custom ops. So we import an ONNX operator, we've been using the Torch custom op uh, as a Torch custom op. Then what we do is, using the pattern rewriter, instead of directly lowering that op, we translate that custom op into the Torch A10 dialect op, and from there the path is all easy and already being part of the Torch-MLIR. So we, when we have it as the Torch A10 dialect op, so the support is already there for the Torch, the A10 dialect ops to the lineage or to the other lower level dialect paths, to the TOSA and the other paths. So from there we take it up from the Torch A10 dialect op to the lineage, and from there we follow on the same path that we use for the Shark, compile it via AD. So the reason for doing this is, let's say if we have to run the ONNX, any import any of the ONNX model and run it via ARI, then we have this model in the ONNX dialect level, and we have to add the lowerings to the lineage or some other, let's say, the lower level dialect, which is kind of supported via ARI compilation. But by doing it this way, we are eliminating the need of adding all those lowerings from the ONNX dialect to, let's say, some of the dialect of our interest, and eliminating that path, and we are just importing the ONNX ops into the Torch custom ops, lowering it to Torch 8 and dialect ops, and then from there we already have the path. So this is in some sense kind of also expanding the support that the Torch-MLIR provides, and as a part of importing all the ONNX operators and the model into the Torch-MLIR, we are expanding the infrastructure that is present in the Torch-MLIR, because we need to support a lot many other ops that are available there in the ONNX. I have an example to show here. So first I will move to the example. So in this example, you can see that using that Python importer that we have in Turbine, we have imported an ONNX operator add. So when we import an operator, we see this kind of an IR. So here you can see there that ONNX.add is the ONNX operator add, and it is imported as a Torch custom op, initiated with prefixed with Torch.operator, and you can see the arguments. And now what we do is, using the pattern rewriter, pattern matcher, we would just translate this Torch custom op, the ONNX.add, to the Torch A10.add op. And here you can see we ran the pattern rewriter over the IR, and we have now it in the Torch A10 add.tensor op. And for this op, we already have the lowering to lineage. So from here, we don't want to actually add too much of the support because it's already present. So this is the same. This way we are adding most of the ONNX ops, but not all kind of ops or all of the ops can be supported this way. There are some complex ops as well, so that would need some special type of handling. So let's say there is an op called torch ONNX, a fine grade, or let's say another complex ops, some mathematical ops that are doing multiple things. So in the Torch-MLIR, what we do for those kind of ops is we write some decompositions for those ops. So but for the ONNX importer, since we are importing them as a custom op, so then we have to replace that custom op using the pattern rewriter with a set of different ops that would be just replicating the same logic that that particular op is doing. So I have a list. From that list I want to name a few of those ops. So let's say there is a Fourier transform op that is present in the TorchOnnx. So that can't be directly lowered to or mapped to any single op in the Torch-MLIR, because PyTorch don't have any such op. So in that case, what we need to do is we need to map that Fourier transform op from the ONNX to a set of different ops in the Torch 8 dialect to just to simulate the same functionality. So this is a brief overview. I haven't gone into much of the merits or advantages of doing this. Stella would be the best person to comment on that, since I am helping mostly in the operator support side. But still, if there are any questions, I would try my best to answer them. Yeah, yes, Ramiro.
You mentioned that the decompositions are done by the importer, or they're just normal like Torch-MLIR decompositions.
No, so the ops are just being imported as this custom ops. The importer doesn't do that kind of thing. That decomposition, I'm saying that while doing the pattern rewriting, we would be kind of decomposing this ONNX dot, let's say ONNX dot Fourier transform op, and we using the pattern rewriter, we would be replacing that with a set of Torch 8 ops that would be just simulating the same functionality. So that would be done in the Torch-MLIR in the Torch-MLIR when we are doing this translation of the custom op to an 8 dialect op. The importer doesn't do that, but the importer can be modified or tweaked to handle some spatial ops. Like there are some constant ops where we are creating a tensor using the constant values, so that is not supported in Torch-MLIR natively. So
Mhm.
that kind of ops or things like that could be handled by the importer, and we won't have to worry about like those things being handled in the Torch-MLIR. So that the importer can those things can be done by the importer.
Are there any like weird types that ONNX supports that Torch doesn't support, or is it just like tensors and scalars like PyTorch?
So
You know?
mostly the things are same, but there are some data types that Torch-MLIR doesn't support. Like there are float 8 data type that
Mm.
ONNX has, but the Torch-MLIR doesn't have. So those are the kind of things that we are kind of like that are the kind of limitations that we are facing right now. But we have to find out a path to support those things as well. So those are some of the data types, and there are many of the test cases. So actually what Stella has done using this importer generated a kind of like more than thousand of the test cases where we have this the operators being written in the custom op form. And what we do is we just take that custom op IR and add a pattern rewriter for that, and just lower that to the Torch 8 dialect op, and just do the unit testing. We don't have the end-to-end test cases. So basically there are three or four uh, different ways of contributing to this, like, so, or the missing pieces that we need to add. So let's say there is a ONNX op, and we need to write a translation to the 8 dialect op. So that is the first step. From
Mhm.
there we have this 8 dialect of. Now from the 8 dialect of, we need to have a lowering to lineage. So there are some ops for which we have the torch to lineage lowering, but there are some ops as well for which we don't have torch to lineage lowering. So let's say there are many of the trigonometric ops like the a cos or a sine, for which we don't have torch to lineage lowering. So there we need to add. So that's the second place where we can have this support. The third place is that we might be having the torch to lineage lowering, but it doesn't support all the cases that ONNX want to support. So there might be a chance of improving that lowering. And the another place is that even if we have the torch to lineage loading, right now we don't have a way of testing them end to end. Like are the ops that are being translated to the torch dialect ops, are they functioning the same way? Because they are just the unit tests, they are not the end-to-end tests, so we are not able to verify the actual computations that are being happening. We are just we assume, okay, this is the ONNX op, and when
Mhm.
we are translating it to this particular torch op, it would behave the same way, and that is our that we assume. So that would be done when we would be having the importer inside the Torch-MLIR, then we would be able to support the ops. So as a first step, we are trying to support the ops that we can support, like the more ops we can support from the ONNX. The second step would be, once we have the have the op support, a substantial support of that ONNX operators, then we could try lowering the set of models that we want to lower through the ONNX path. Because if we try it right now, since we don't have the op support, so that is not going to work out of the box. So that would be the second step. So the contributions are very much welcome to this project that we are working on. So I have created this a spreadsheet where you will find three different sheets. So one of the sheets specifies the torch to lineage lowering present, so that is the set of ops for which we already have the torch to lineage support. And the another sheet specifies the list of ops for which we don't have torch to lineage lowering. So that would be a two-step work. First, we need to add the torch to lineage lowering for that op, and then we need to add the ONNX to torch pattern rewriter or the translation for that op. So that would be a two-step process. So, and we have also kind of I have like just on the basis of my wisdom, I have kind of rearranged this list based on some, and tried it to prioritize it, and I have just prioritized it based on whether the op is simple or a complex one, whether we have the torch to lineage lowering or not, whether we have an MLIR corresponding MLIR op or not, or whether this kind of ops appear more frequently in the set of models or less frequently. And based on that, we have added this. So uh, like if anyone wants to contribute, you can just go to this sheet, write your name in the owner column corresponding to that op, and start working on adding that. So if you want to know how to add the op support, so here in the first sheet I have added a link to a readme which Stella has added, and this clearly defines the which steps to add an ONNX operator translation to the torch rate and dialect op. And the steps are quite easy to do that, so it's not kind of a very tough thing to do. But so the contributions here are very much welcome. So yeah, so this is on a higher level how the things are going to work, the ONNX importer and all those stuff.
Nice. Is there uh, like some end-to-end examples uh, in like a Shark repo or not yet?
So right now in the Shark repo, you won't find in the, so Stella was able to generate a generate able to import the ResNet model using the turbine importer that we have, but
Hmm.
that ResNet model has been in the Torch operator customer form. It's not, it wasn't like we were able to generate it or lower it end to end, because
Hmm.
there might be some ops for which we need to add the support in torch to lineage, and we need to have the patterns for all those custom ops. So that is a work in progress, and till the moment we don't have that, so we won't be able to lower any of the model. So
Right.
that is the highest priority that we are trying to do. So there I found just one limitation here, and Stella might be having some plan for that. So the limitation is that when we are importing the PyTorch model or PyTorch op using the FX importer, we have a way of applying the upstream PyTorch decompositions using the FX importer, and
Hmm.
that decompose the original PyTorch op into a set of other basic or simpler PyTorch ops, and we can add the support for those ops. But when we are just importing the ONNX operator into the Torch custom op, so in that path we are not able to apply those fx transfer fx decompose the PyTorch decompositions, because the importer is not the same. So when we have, let's say, a complex of for which we have a decomposition in PyTorch, in this case what we have to do is we would have a custom PyTorch op and I don't think on that custom PyTorch job we can apply that the upstream PyTorch decomposition. The only thing that we could be able to do here is the simulate the same PyTorch decomposition that we have in upstream in the Torch-MLIR, and then decompose that custom op into those set of ops and then lower it. But there might be some other solution to this, or we can try to figure out the solution to this, so
Hmm.
that would kind of like make more anything simpler. And if we are not able, so then we have to work on many of the op support that we were making use from the upstream PyTorch decompositions. We need to have them natively supported in Torch-MLIR.
Right, makes sense. Uh, so
Yeah.
like ONNX has its own sort of graph, their own FX similar type of graph that you're using, so that's why you can't apply things to it, or is it also turning into a TorchFX graph before importing?
So for applying those applying those PyTorch decompositions, we need to have it in the form of an FX graph, but we are not having it in the same form. So like we
Mm-hmm.
are having an ONNX graph instead of an FX graph, and
Right.
on an ONNX graph, I don't think that we can apply a PyTorch decomposition. So that is kind of a reason that why we aren't able to do that thing. And
Mm-hmm.
ONNX has its own set of like protos and buffers are the native kind of basic units in which the graph is represented in the ONNX. So it is kind of a bit different from the PyTorch or the FX graph. So
Yeah,
that is why we are not able to use the same decomposition in the similar fashion here.
makes sense.
Yeah, so that was all from my side. I hope I was able to explain it at least in some basic detail.
Mm-hmm. Yeah, thank you so much for this. Yeah, this answers a lot of my questions. Awesome. So yeah, with that, thank you, Vivek, for presenting on this. And yeah, that's it. We'll see you all on the next community meeting.
Yeah. Thank you so much and bye.